So hello, my name is Joe Lopez and I'm the head of sales of Emberion. And Emberion is a high-tech company located in Helsinki, Finland.
And what do you do?
Well, Emberion has a long heritage. We're a spin-off company from Nokia in 2016. And since then, we've been developing image sensor technology using a quantum dot approach. So we differentiate ourselves versus the vast majority of other companies because they use in-gas technology, we use quantum dot. So here at our booth, basically, we're demonstrating one of the world's first and perhaps most advanced quantum dot cameras.
So show me the demo.
Okay, so this is the camera. So here we have the VS20, that's its official marketing name. And it has a C-mount for the lens and basically a GigE output to connect to your computer. So this is the camera, and then we basically have here a demonstration of the spectral range capability of the camera. And the best way that we can do that in an exhibition like this is basically to have an LED display. And then on this monitor, you have the image that the camera is seeing.
But I can't see any light from the LEDs.
No, you can't.
Why is that?
Well, because it's beyond the human spectrum and it's actually beyond the spectrum of your camera. Your camera has a limit in terms of its visible spectral range.
Okay. So where will I find your technology?
Well, our technology is incorporated into this camera from start to finish. I want to kind of emphasize that. This camera is developed 100% in Europe, so it's European sovereign technology. We design the sensor, we design the VLSI ROIC, CMOS chip. We deposit the CQD material on that chip. That's done in our facility in Cambridge in the UK. We basically assemble the component onto a PCB, integrate it into a camera with software and hardware, and we sell these cameras around the world. And we ship them from Helsinki to our customers.
Who buys them?
That's a very good question. And actually, there are many applications for these kind of cameras.
Can you give me some examples?
The farming industry is one area where it could be used, for horticulture, for example, for plant health analysis. The biomedical industry for different kinds of applications in relation to human body, in terms of skin, for example, teeth, etc., things like that. And also fluid analysis and chemical analysis within the pharmaceutical industry.
And why is this approach better than competitors?
Well, the differentiator of our technology, as I've kind of mentioned previously, is that it does not use in-gas. So in-gas is relatively expensive. It is a hybrid wafer approach, so a CMOS wafer with an in-gas wafer bonded together. So it's complicated to produce. It doesn't really offer scaling, which our technology does. So we use a CMOS wafer with a spin coat process to deposit the CQD material. So these could be 8-inch wafers, they could be 300 millimeter wafers, and obviously that provides tremendous scaling in terms of volume. And with volume, also there is a significant drop in price.
So is Emberion a startup or scale-up or a big company?
Is 10 years old. We were founded in 2016. We have 3-4 investors. We are privately held at the moment. We are looking for more investment to basically increase our capacity and improve our yields so that we can support the customer demand that we are starting to see. We actually have more demand than we can produce at the moment. So we need to scale our production.
And roughly what does a camera like that cost?
In the range of about 10,000 euros for a single evaluation unit. But in volume, these cameras could go down to 1,000 euros or even, at the sensor level, to 50 to 100 euros each.
Okay. Now, you've got some videos here. What are you talking about?
We're basically demonstrating the sort of typical application of these kind of cameras. And here we have one which demonstrates the camera being used in an automotive application to improve the visibility in rain and snow in Finland in that particular case. So we had a comparison then on the left with a visible phone, basically like an iPhone, and then with our camera on the other side of the screen.
And what are you doing with defense?
So defense is obviously a big part of our, let's say, business and customer demand at the moment because of the situation that we're all experiencing.
Right.
And in defense, we have a particular capability in daylight conditions. So SWIR is more tuned to daylight. And here we have an example of a smoke grenade and a soldier walking behind it. The picture here on the left is with a SWIR camera, and the picture on the right is with a normal visible camera. And you can see that in the case of SWIR, the soldier is quite visible behind the smoke, whereas in the case of visible, he's obstructed by it. And smoke is just one example. We could be talking about haze, we could be talking about dust, we could be talking about fog. These are all applications of our camera. In this case, we have a laser rangefinder, and you can basically see the dot of the laser on the vehicle with our camera. And with the visible camera, obviously, you can't.
SWIR stands for shortwave infrared, but explain a bit more about that.
Okay, so shortwave infrared is basically between somewhere around 1,000 to 1,700. You have visible from 400 to 700, then you have near infrared from 800, let's say, to 1,000. Shortwave infrared from 1,000 to 1,700, and then you have this extended shortwave infrared from 1,700 to maybe 2.5. And our camera covers from 400 to 2,000 today. Soon we'll be able to cover up to 2,500, and in the future we expect, and we are developing 3 to 5 micron image sensors, also using quantum dot technology, but a slightly different chemistry from what we use currently. Today we use a lead sulfide quantum dot, and in the future we plan to use a mercury telluride quantum dot, which will give us this extended spectral range up to 5 micron.
I've got you. Quantum dots are definitely booming, aren't they?
They are indeed, but they're not an expensive item. So we're basically building our sensor using low-cost silicon wafers and low-cost quantum dots. So it's the Picasso analogy. It's not the cost of the paint, it's basically what you do with it. So that's our value added.
This is the first time you've attended the Global Photonic Economic Forum with a booth. What are you going to take away?
It's a pleasure to attend the Global Photonic Economic Forum here in Malaga. It's personally my first time to Malaga, and it's my first time to this forum. My takeaway is that the level of understanding and knowledge across the photonics industry is really perceivable here. And I would say as a European exhibition, it is one of the best in terms of our ability to engage directly with our end customers. And not only that, but the high-tech CTO engineering managers within those companies, which is exactly what we want to do. And as a result of this event, I can honestly say we've gone away with purchase orders, which is the reason why we want to be here.